All right, so we're on lesson 5.2, page 306, and we have a word problem. We have a scenario, and the scenario runs like this. At this moment, the population of downtown is 20,000. The population of uptown is 6,000. But over the years, people have been moving away from downtown at a rate of 1.5% every year. Urban flight. At the same time, uptown's population has been growing at a rate of 1.8% each year. Okay. So, first question is asked is what is the independent and dependent variable in these situations? Quantities. And so if we think about that a little bit, okay, so over time, the population is either growing or getting smaller. So what depends on what? That's the way I always like to think about this. And if you think about that for a second, the population depends on how many years have gone by. So the population is dependent and the time is independent. Let me ask you, which one of these two places, downtown or uptown, would be a decreasing function? And I think since the population of downtown is decreasing, I think it's pretty obvious that your function would be decreasing. So downtown is going down. Which is an increasing function? Well, it said that the population of uptown is growing at 1.8% per year. So that would make uptown the increasing function. And they give you a equation that will tell you how much it'll be after 1 year. So we start with 6,000, that's our original population. Then we're adding the growth. Now the growth is 0.18% per year. And we're going to switch that to a decimal by moving it we're going to switch it to a decimal by moving the decimal 2 to the left. And so it's going to look like this. This is just like an interest problem, by the way. If you're used to interest problems where you figure out the interest, add it to the principal, it's the same thing. Here we're adding the base, and this is what we'll call it our growth. And if you do the math, you'll come up to 108. And so after the first year, the population will be 6,108. Now, where is it going to be 2 years from now? Well, let's think about that. The starting figure is now, the base is now 6,108. And so we're going to multiply that base by 1.8% growth. And now we're going to have a new number, and that number is going to be 6,217.944 if you took it out all the way. So I'm thinking that's a little odd. You probably wouldn't have 9/10 of a person. Why don't we just round it off and say 6,218 people. Okay? So our growth was 218, rounded up. Now, 3 years from now, what would your setup be for that problem? So I tell you what, stop the video, do the setup, and check and see when you restart if we match. Stop it. Okay, welcome back. Now, what you should have done is put in 6,218 as your base, and then you add 6,218 times that. Okay? All right. Now, you can do this. If you were asked, for example, to find what's the population 10 years from now, you could do it step by step, and you'd come up with the right answer. The thing is, there's an easier way to do it. If you use the compound interest formula, it's a whole lot faster because this is your setup. Here's the base, this is the growth, and you add 1 to that, and your exponent hanging out on the outside there is the number of years that have passed. So if you take your calculator, you probably wouldn't want to do this by hand, and create your problem like this. Let's say the second year. So that would be squared. this would be squared, then multiply it times this, you'd come out with the same answer, 6,218, for a whole lot less effort. And obviously, if you were doing 20 years from now, 30 years from now, it's going to be a whole lot easier. Now, one thing to notice, the growth is not linear, okay? Because the first year, it grew 108. The second year, whoa, that's a big jump, 218 more people. And the third year is going to be even more. So this is not going to be linear. This growth is going to be exponential. If you go project into the future, your growth every year would become quite substantial. Okay? All right. So in our next video, we're going to be basically doing the same thing, except this time we'll look at downtown and we'll see the decreasing.